I'm going to walk you through some details about this work here. We did this in class. We talked about this in a whiteboard seminar circle, but you probably need to spend more time with it if you're having trouble with this content assessment here. So first of all, this is Greenland, but we can model Greenland with a much simpler shape. So the first task here is to think about, like, how can we calculate the volume of Greenland. And we have some volume formulas to work from, like this cylinder volume. It's not a cylinder, so that doesn't super help. Length times width times height for a rectangular prism or a cube. I'm going to suggest something slightly different, which is to use the fact that volume of the shape is equal to the area of the top of the shape times the height. Notice something like this formula here, is actually using that same thing. So when we say volume equals width times length times height, notice the width times the length, that is like these two values multiplied together, are actually an area. And they're the same area as the top of the shape up here. So another way of writing this would be V equals width times length in parentheses, because width times length is equal to area, times the height. So that would also equal area times the height. Let me show you what that looks like for this funny shape here. So the first step would be to calculate the area. I'm gonna do that in two parts. I'm gonna multiply 1,000 by 1,100, and I'm gonna get the area of this is equal to basically add 3 zeros on the end of this number, because I'm multiplying this number by 1,000. I add 3 zeros to it. Down here it's similar, but I have to divide the total by 2 because it's a triangle. So I'm going to multiply the same length times width, but then I'm going to divide it by 2 because I've only got half of that shape. So this is going to end up being, this area is 550,000. Units on these are both kilometers squared. What do I have to do to figure out the total area? I would add those together and I get 1,650,000. It's a little easier to think about this in scientific notation, but I'm going to leave it this way for now. Now, we're not done yet. We had to say the total volume is equal to this area times the height, meaning how thick is this Greenland ice sheet? We can tell down here that it is 1.5 kilometers thick. So if V equals area times height, that means that V equals 1,650,000 times 1.5. I'm going to have a hard time doing this in my head, but whatever the answer is the volume we're looking for. Let's see. I kind of need to do it in order to move forward. Let me see. I think I have an answer over here. While you're waiting for me, you should be multiplying this yourself to see if the answer that I get is similar to the answer that you get. What I end up with is this. 2.5 times 10 to the 6th, or move this decimal place 6 places over, so that's going to be 25 with 5 more zeros. So notice if I use this scientific notation, 2.5 times 10 to the 6th, I'm going to move the decimal place over 6 places. 1, 2, 3, 4, 5, 6. This volume is the volume of the ice sheet of Greenland. Now, a lot of people were able to figure out how to do this, but they weren't able to figure out how to apply it to this question. This is where it gets kind of tricky. Use our math model from our lab work to calculate how much would Earth's sea level rise if all of Greenland's land ice melted into the ocean. The area of Earth's oceans is 3.619 times 10 to the 8th kilometers squared. Okay, so first of all, we recognize like the area of Earth's oceans is not a rectangle. Like the Earth is not flat, contrary to some people's belief. The area of Earth's oceans, if we were to try to calculate it, is pretty complicated. But we don't have to calculate it because it's given to us here. And in order to do the problem, we can model the Earth as a flat rectangle because it makes it easier to think about it. This flat rectangle has an area of 3.6 times 10 to the 8th kilometers squared. So just like we calculated the area of the top of Greenland, and we knew that that was connected to the volume, we can calculate the area, or sorry, we didn't calculate it, but we read the area of the top of the surfaces of the oceans, and we can relate that to volume. Think about it like this. When we start with an ocean that looks like this, so it's got a certain thickness, and it's got a certain area. When Greenland melts and dumps into the ocean essentially gets thicker. Like we add some more Post-its onto the top of the ocean. It's probably not this much thicker. It's probably just like one Post-it thicker or something. But the idea is there is some change in thickness of the ocean shape as a result of Greenland melting into the ocean. So this shape here is going to change. It's going to get thicker. And I'm going to draw that here. The amount of thickness that's gone up is equal to the change in height. That's what we're trying to solve. Now, what is the volume of this shape? Not the shape on the bottom. This is the volume of the whole ocean. We don't know that actually, because we don't know how deep the ocean is. But what is the volume of the increase? Well, why did the volume increase in the first place? Greenland's land ice melted into the ocean. This volume is equal to the volume of Greenland that we calculated earlier. This volume of, here, I'll write it like this. Volume of melted water equals the volume of Greenland ice. So that means the volume I'm working with is equal to 2.5 times 10 to the 6. 2.5 times 10 to the 6 kilometers cubed. Remember how we're going to use this. The same way that we thought of volume, area, and height earlier, we're going to use that same idea here. Volume is equal to area times height. I know the area because it's given to me here. And I know the volume because I calculated it earlier. So I need to substitute into the equation and solve. Notice this is the way I always like to do it. I'll substitute it directly below the equation I'm using so that I don't get confused on what goes where. I don't know what the height is, so I can't substitute for it. Notice this is a 3.6, not a 36. And then I would divide both sides by 3.6 times 10 to the 8th. 3.6 times 10 to the, times 10 to the 8th on this side too. So on this side, it all cancels out and I'm left with h. On this side, I've got some division to do. So whatever this is equal to, h is equal to. The way I like to think about the scientific notation, by the way, here is to just like split it up. When I divide 10 to the 6th by 10 to the 8th, I know that because the base is the same in both, I can just subtract the exponents. So 10 to the 6th divided by 10 to the 8th is 10 to the negative 2. And then 2.5 divided by 3.6 is around 0.7. You can check me on the calculator here. But my final answer is 0.7 times 10 to the negative 2 kilometers. If I want to turn this into a number that makes more sense, if I'm not good with scientific notation, I would move this decimal place 2 places to the left. Notice I'm making the numbers smaller because it's a -2, this ends up being 0.007 kilometers. This is about 7 meters. There's 1,000 meters in 1 kilometer. So this is approximately 7 meters of sea level rise that we'll get if all of Greenland melts and goes into the ocean.